want to talk about in this video is why we can look to the dominating terms on the top and the bottom. The dominating term over this entire function is this x cubed. So let's imagine dividing everything by x cubed real quick. I'm going to go ahead and simplify. So 4x cubed divided by x cubed leaves me with 4. X squared divided by x cubed will leave me with 1 over x. X cubed divided by x cubed is 1. And 2x divided by x cubed will leave me with 2 over x squared. Now, if I imagine plugging some really large number in for x, I have 1 over some really huge number. 1 over some really huge number is going to get really close to 0. So we can treat this number as if it's 0. Same here. 2 over some really large number squared is going to be really close to 0. So we can treat this number as if it's 0. Then we're just left with this 4 divided by 1, which is 4. What we found in that explanation is that these things really aren't going to matter because these aren't the dominating terms of the numerator or the denominator. If I go back here, x squared gets dominated over an x cubed and 2x gets dominated over an x cubed as well. So if we just look at this simplified part, we have 4x cubed over x cubed, and x cubed divided by x cubed makes a 1. So this limit is equal to 4. So we're getting the same answer here. And you can use either strategy to evaluate the limit. Okay, let's take a look at this problem. If we use the second method, we can look at what dominating terms don't matter. The dominating term on the top here is going to be this x squared term, so I can just ignore this constant term. The dominating term here is also going to be this x squared term because that dominates over that x to the first power. So what I'm left with is this, and x squared divided by x squared will make a 1. So my limit as x approaches infinity is just 5/3. What we're finding here is that when my dominating terms are the same, we can look to the coefficients. Now let's consider something else. What if my dominating terms are not the same on the numerator and the denominator? In this example, my dominating term is 3x to the 4th on the numerator and 6x to the 3rd on the denominator. If I take a look at this and simplify, x to the 4th divided by x cubed will leave me with 1x on top, and 3 divided by 6 is 1/2. So I have 1/2 x. And if I take this limit as x approaches infinity, I have 1/2 times some really huge number. And 1/2 times some really huge number is going to approach infinity. So when a limit approaches infinity, we see that the limit doesn't exist. But sometimes it's nice to talk about the direction that it's going. So we'll say something like, the limit doesn't exist, however, y is going to approach positive infinity. Now what if instead I have a negative on my dominating term? Dominating term is still this on the top. Dominating term is still this on the bottom, but now this is going to simplify to negative 1/2 x instead. If we plug infinity in here, we're now going to go towards negative infinity because of this negative right here. So if I have a negative on the top or a negative on the bottom, a negative divided by a positive or a positive divided by a negative will get me to a negative. So this one, again, would be a does not exist, but y is approaching negative infinity. The last scenario we're going to investigate is when the dominating term is on the bottom. My dominating term on my numerator is 3x to the 4th, and my dominating term on the bottom is 9x to the 5th. If I simplify this, well, 3/9 simplifies to 1/3, and x to the 4th divided by x to the 5th simplifies to 1 over x, so I'm just going to extend that a little bit to put the x on the bottom. If I put in some really large number for this x right here, I'm going to have 1 over some really big number, and 1 over some really big number approaches the number 0. So the limit as x approaches infinity is 0. So in this case, when my dominating term is on the bottom, I'm going to go towards 0. Let's investigate one last item. So in this example, I have a bunch of different things. I have a power function, I have an exponential, I have a log in here. So again, I'm just going to try to find the dominating term. The dominating term on the numerator is 3 to the x. And my dominating term on the bottom is x cubed. This won't matter, this won't matter, this won't matter, and this won't matter. So what I have here is I have a dominating term on top because exponentials dominate over powers. And when I have a dominating term on top, this is going to go towards infinity. So this one is a does not exist, but y approaches infinity. We can use these ideas here outside of power functions as well because exponentials dominate powers, dominate logs.